Uh, it's important that we put on record the tools that are required. One of them is the compass. This we use to generate circles. The other tool is a straight edge. This we use to draw lines. And of course, it's very important that the plane is where we will introduce what is in our wetwares. And so, to deal with the question or the proposition raised by Euclid in his first proposition about how do we construct a regular form from a straight line. Before we go into that, we'll take the privilege to let you know that once we have 2 points on a plane, there are few things we can do. One, we can draw a line segment from one point to the other. Two, in fact, for vocabulary purposes, let's just call this first point A and the second point B. So we've drawn a line segment from A through B, and the other rule says we can extend, like I'm doing, to the right and to the left. These are line segments. So we've already answered the question from a straight line, part of it. The straight line, for us to do the straight line, we put those 2 points, and then we draw a line segment from point A through point B. And then we extended that. Doesn't matter. We center our compass on point A, going through point B, we construct a circle. We center our compass back on point B, going through point A, we construct a circle. We can invoke some of the masculine principles here. These two circles create this point above and below. We draw a line segment in green from this crossing of A and B above and the crossing of A and B below. We can draw a line segment from this crossing. In fact, we can name this crossing C and this C prime. They are just vocabularies. Can be 1, 2, 3, 4. Can be space-time particle wave. It could be your physical self, your mental self, your creative self, and your spiritual self. It can be the color red, yellow, blue, and black. When we draw a line segment from point C to point B, we draw a line segment from point C to point A. And we draw a line segment from point A to point C prime and from point B to C prime. You notice that an equilateral triangle ABC above, the AB line separates the concept of above from below. And for symmetry purposes, you notice also that we have A, B, C prime. These are regular forms. The inquiry by Euclid to the students is unfolding, and that's the way. Then we notice also that when we drew this line segment, we came to this crossing. This crossing was not there initially, and we came to this crossing. These are things we're supposed to have mentioned before. Now, I'll draw a line segment, use color coding to separate some of like the black circle form from this green circle form. That's the form. The regular equilateral triangle above, equilateral triangle below. And in the process, we still found out that another equilateral triangle in green and another equilateral triangle in green. Okay. We are going to attempt, to show in terms of our goal, how we can generate the square root numbers. But before going into that, I want to, bring into our consciousness an abstract, during the Conference on Scientific Computing at the National Mathematical Center, August 14th through the 20th, 2011. At that conference, we were able to unveil the rational number objects, and the abstract that we presented is one of the things that we are going to be performing here today, the articulation of concentric families that are generating square root numbers. This is the form. So our goal will be to synthesize this form. To get to this form, there are few things, systematic approach that we invoke. On a blank sheet of paper, we put two circles, 2 points. We center our compass over here, going through this process. We construct a circle. And back here, we do the same thing. It's about the crossings. We notice there's a crossing here. We center our compass there, and we do that. I know where we are going. The audience or students have to just follow me patiently. And I hope we are following. This pattern of crossings enable this point and this point and this point and this point. So at this point here, put another circle. At this point here, we introduce another crossing. At this point here, we introduce another crossing. And then at this point here, we introduce another crossing. If you notice, we have 8 circles here, and they are all of the same radius. We took this distance. When I say this distance, this point to this point. So again, for vocabulary purposes, I'll call this A, B, this point C, D, this time E, F, G, H. So now I can instruct the student, the teacher, whoever, the child, whoever is doing this drawing, the teacher, students, parents, you draw a line segment from A to B and we extend it, line segment, on either side. I know where we are going. You see, when we replicate AB, we add this distance. We add this distance from here to here. We add this distance from here to here. And this we can do infinitely. Let's add some more circles so we can take the advantage. The same radius. There's a new crossing here. With that, we continue back here. We have another one. On this side, we can replicate this distance AB. So for counting purposes, this is how counting came about, for us to replicate. So we can say from this distance to here, we say it's 1, then this will be 2, this will be 3, this will be 4, and so on, infinitely on the number line. So if this is 1, and this is 2, this is 3, this will be 4. What we are saying here now is that what we call 1 is actually a distance we took, that this number here should be the square root of 1. So AB, we take the position that AB is equal to square root of 1. Watch me, it's imperative that this was the way this stuff was taught. The teacher shows the student, do this like I'm about to do. This crossing here, I want a line segment that goes through the point B, and I can find that with the crossing of the D and the G circle, where they cross over at this point, and the C and the F circle over here. So I draw a line segment in green. That enables us to have this point and this point. That's what I'm looking for. We'll do the same thing. Draw a line segment going through point A. That gives us that. This enables these 4 points. You notice immediately that point A, maybe let's label for vocabulary purposes. We'll just keep on labeling. If this is A, B, C, D, we say E, F, G, H. Then let's do this new crossing as I, J, K, L. I guess we're doing this for television, and I think it's almost time and we'll continue, but continuing from here, we have established these points I, J, K, L. If we draw a line segment in blue, from I to B, since this is a square, AB, IJ is a square, so, and if AB is equals to square root of 1, so AI will also be equals to square root of 1. And that means we have to look for IB. Using the Pythagorean theorem, AB square plus AI square will be equals to BI square as the hypotenuse. So this will be the square of the square root of 1 plus the square of square root of 1, which is AI, is equals to BI, the hypotenuse, which is the diagonals of the square. That's what we are looking for here, the diagonals of the square. This will give us 1 plus 1 is equals to BI square. BI, therefore, will be equals to the square root of 2. So, the diagonals of the square IJBA is the square root of 2. Now we take our compass, that's the number precisely, square root of 2. Excuse me. We center our compass at the point B, going through point I. We construct the circle in blue, and that's why we're using the center at A. It will go through J. We construct a circle. So we have we have two concentric circles centered at B, this black circle and this blue circle. We have two concentric circles centered at point A. This we took as the radius, this black circle as the radius of square root of 1, and this blue circle, which is the diagonal of the square and which is the radius of a circle, a number that is square root of 2. We can extend this further, and it goes on. When we extend this line segment, we can now find this distance. And since we don't have names for them, I, J, K, L, M, O, N, O, P, M, N, O, call this one, this point here, P R S T. We center our circle. What we're about to do now is we want to construct or compute this distance BP. We already know this distance AB, and we know this distance. We know this distance. We're looking for this distance. We're looking for this distance. We already know this distance, AB. Okay? We'll have to revisit this. Actually, what we needed, that was a mistake. The distance that we're looking for is this crossing. Is this crossing, not this. We'll get to this later on. But so what we do, I guess we're going to have a timeout, but to recover is this point, whatever this point is, this point here. Center our compass over there, and we do this. And we center our point over here, and we do this. We're going to get back to that one here just now. Good. These green circles will be square root of 3, because from here to here is already square root of 2, which is the radius of the blue circle. And from here to here is square root of 1. So what we are looking for is this distance from here to which we found out to be square root of 3, and it's in green. Time out.